Assalamualaikum and hi. I am Nur Fatinah binti Majufri from Group 11. I will explain about phase 1. In phase 1, we are required to do the two part, which is plotting the signal and need to do the convolution from the signal. In part 1, we need to plot all the ECG signal with different frequency, sampling frequency. The frequency given is 1000 Hz, 200 Hz, 50 Hz, and the last one is 10 Hz. And when I run this coding, I get this graph. All these four ECG signal in different sampling frequency. How I managed to get this all these four graph in one figure is I use the function of subplot. For the second part is we need to do the task is we need to do the convolution signal. Convolution signal, first we need to plot the input signal, which is XN, XSN, and HN. And last part is we do the convolution. And when I run this program, I get this. So this is the input signal, and this is the convolution signal, which is the output of all these signal. And for this convolution, for the part 2 section, we need to compare the theoretical calculation and also the MATLAB simulation. From the theoretical calculation, I get the same as the simulation from MATLAB, which is SN, XSN, and this is the way we do the convolution. And the last one is a convolution. And we managed to get the same the simulation and also the calculation. Thank you.
Will be explained further on designing this filter. So our focus is on ECG1, which is 1000 Hz of frequency, as you can see here. So to remove the noise, we need to know where the noise exists. So the question stated that this signal is subjected to 50 Hz of power noise. So to view the noise, we need to convert the ECG1 to frequency domain. So to do that, we use the function Fourier transform. To convert the signal, we define the number of samples and the time in frequency, and then we plot the signal. But at the same time, I will show you the frequency spectrum of the signal when it has been shifted to the center. So here it is, the shifted signal. As you can see here, this is the ECG1 signal after Fourier transform. This is the one with the shifted. So clearly here, between 40 to 60 in the middle is the 50 Hz noise that we need to remove. So this is our filter specifications that we need. We need to set a cutoff. We are going to use a low pass filter to remove this noise and make our system better. My friend Amir will explain further on that. Thank you.
Okay, Assalamualaikum and good afternoon. Today I will discuss about how to do the assignment for phase 3 to filter the ECG1 from phase 1. Firstly we will put the value of analog frequency, that is much less than the noise frequency, 50 Hz, and then we declare the sampling frequency, that is 1000, given from ECG1 phase 1. Then we will divide both of them to get the cutoff frequency. From that we will get the omega c, that is 2 pi fc, and put the sampling for 20. And then we use m, that is n plus 1 from the formula, this one, notes, there is Hamming for m minus 1. If we convert, we will get m plus 1. From that, we will use the function from MATLAB, that is filter, put the value n, omega c, and Hamming for m, and then we convol both of them and get y. From that, we will do the plot one for ECG, that is the original system signal, and then we plot the y, that is filter, that is convol from H and ECG, and then we will run the program. This is the original signal ECG1, and this is the filter signal. That is why ECG1 convol with H.
So if we compare the frequency spectrum of ECG1 and the new ECG1 that has been filtered, we can see that the noise at 50 Hz has been filtered out and thus gives us the desired response, the desired signal of the ECG1 without the noise. That is all from us. Thank you for watching.